this video, we're going to talk about 12.1 Objective 2, where we write complex numbers in terms of I and J. None of these things are actually going to use I, but the idea here is that if we wanted to talk about a complex number as a two-dimensional vector, that we could talk about this is the I component and this is the J component. And we do talk about things that way a lot with vectors, and the complex number is somewhere out here in a something like that, but we'll get there. That's why we're using I and J is in the vertical direction, and that's why we're using that as the imaginary unit. But everything here, we're going to just be talking about imaginary numbers here. So this is going to be the square root of 9 times J is going to be 3J. And this is going to be the opposite of that. So this is going to be a negative 3J. And so this is going to be exactly J times the square root of 2.89. 289 is the perfect square of 17. So this is 1.7 J. Let me prove that to you. See, 1.7 times 1.7 is 2.89. You can use your calculator and prove that to yourself that the square root of 2.89 is 1.7. 4 times J times the square root of 27 is going to be 4J times 3 times the square root of 3 is going to be 12 root 3J. Split this up into the square root of -5 and the square root of 144. And this is going to be root 5J. And this is going to be 12. Root 5 over 12J. Okay, and I do like that they do this. I'm just going to go back and do it the way that they did it, that they put the square root last. I like that also, because order of multiplication doesn't matter, and it clearly shows what's inside the root sign, so you don't think that the J is inside the square root. So they would have written this as 12J root 3, and they would have written this one as J root 5 over 12. All right, we'll come back next time and talk about 12.1 Objective 3. See you for the next video.